Good day, I'm Martin Gagel with Market Radius Research. It's Tuesday, July the 19th, 2022. We've got Michael Liik of Cymat Technologies joining us. Cymat is a materials technology company specializing in stabilized aluminum foam, a strong, lightweight, recyclable material with many valuable attributes. It's great having Michael on with us. I first met Michael probably about 15 years ago. Cymat has some very interesting technology with uses in multiple sectors of the economy. They've just announced a component development agreement with a global car manufacturer to develop an electric vehicle battery enclosure. But please remember, this is neither a recommendation nor investment advice. We're here to learn about the company. Michael, thank you very much for taking the time to join us here. And please tell us about Cymat.
Thank you, Martin. Well, welcome everybody, and thank you for taking the time to hear about Cymat. It's a very exciting time at our company right now. It's something we've been looking for many, many years to break into the automotive industry and what have you. I'll leave that sort of for the end, as I'll dig a little deeper into it than some of the other aspects of our business. But I'll talk about the business. If you're interested in seeing a pitch deck or that sort of thing, you can get that from our website, but I generally just prefer talk about the business. So if that's okay, I will kick it off.
Let's go.
So as Martin said, we are an advanced materials company. It's principally aluminum foam that we have developed and commercialized and what have you. If you want to picture what aluminum foam looks like, think about an aero bar that's made out of aluminum. It's got some very interesting properties, particularly the engineering properties. First off, it's very light. So it's aluminum, which is a light metal to start out with, but it's principally air. So it's anywhere from 98% air to higher density, stronger foams that are as much as 50% air, 50% aluminum. But we can customize the cell structure of the lattice to virtually any cell size, cell thickness, cell wall thickness, density. So everything is bespoke based on the application that we're designing for.
And Michael, I like your aero bar analogy. So if you cut an aero bar in half, you see all the little bubbles. That's what your aluminum looks like. It's got little bubbles in it.
Yeah, it's got a skin on the outside like an aero bar, and inside it is all bubbles, basically.
All right.
So other attributes of the material, aside from it being very strong and light, are that like any cellular material, it's very effective at diverting energy or crash energy. So if you can imagine a solid material, if you hit it, you have instantaneous deceleration. If you hit a cellular material, you have controlled deceleration. And that is very significant and important in, say, car crashes or military events, that sort of thing. The material is not directional. It's got very good electromagnetic shielding properties. It's strain rate insensitive, which is a very fancy term for saying that you can hit it at any speed and it's going to perform exactly the same way. It's got thermal properties anywhere up to R8, depending on how much air is in the matrix. And then
sorry, finally, when you say thermal properties, it's an insulator. So if you put it on the outside of your house in R8 insulation, it would help maintain the temperature.
Exactly. And finally, it's got good acoustical properties as well. So it's been used in concert halls or it can mute sounds, that sort of thing. You can custom tailor the acoustical effects to what you need. So it's got very interesting attributes, and that's what we've tried to exploit over all of these years. So we organize our business along three basic commercial verticals. The first and the one that is most developed for us, and quite literally has been paying the bills for the last number of years, is our architectural and design business. And we operate under the Alusion brand globally with that. I'll talk a little bit more about that, but principally it's We use it for cladding applications, for buildings, some internal features, that sort of thing. But it's principally an aesthetic material. Then the next vertical is smart metal, which is the engineering material. And that breaks down into automotive, military, and nuclear as the three principal areas. Again, in military and in automotive, I'll start with automotive. Its most interesting two features are its lightweight relative to strength. And that's very topical today because lightweighting of vehicles is very significant, particularly for electric vehicles. And then energy absorption. So anywhere you're trying to sort of absorb energy, crash energy, it's very effective for that. In military, it's used principally to deal with the blast wave that precedes an explosion. Most people think of an explosive event as a lot of shrapnel sort of that emanates from the explosive event. Military has reasonably effective solutions for that, or knows how to deal with that through various Kevlars and materials as such that don't allow penetration of these projectiles. What they have a real difficulty with is dealing with the impulse or the blast wave that precedes the explosion. So that's a wave that will go through solid steel or solid materials very effectively. And to use an example, if say a tank goes over an IED, it'll tip the tank over or throw it up a bit. It'll be completely undamaged. But generally speaking, most of the occupants will have deceased. And that's because that blast wave comes through all the armor, but once it gets into your body, into the hollow organs, it shreds the organs. So what our material does is, because it's mostly air in structure, when air meets air, so that blast wave gets into our material, when air meets air, you get turbulence, and that turbulence starts to shred the material. So if you have, say, 100 G force coming up from the ground as it hits our material, by the time it's through our material, it's about 10 Gs. So it's dissipated a lot of that blast energy. That's principally what it's used for in military. In nuclear, it's used for, again, energy absorption. We have applications mostly in the bottoms of or bases of elevator shafts. So if you can imagine when you're transporting spent nuclear rods from a reactor, they're typically stored underground and they have to be transported underground. So the device that transports them, or the elevator, if that ever failed, you'd have a catastrophic event. So we're the last line of defense at the bottom of these elevator shafts and absorbs the energy as that, in the event that the elevator cab comes careening down a shaft. And these shafts can be as far as a half mile underground. So you can imagine the energy that needs to be absorbed to safely bring that cab to rest. So that's our nuclear application. The third leg of our stool or commercial vertical is brazed panels, sandwich panels. We have a joint venture with Alucoil in Spain, where a plant has already been built. And the premise here is that we're looking to take a ubiquitous aluminum sandwich panel, which is typically just two sheets of aluminum separated by either a plastic foam or aluminum honeycomb to create a very stiff, lightweight panel. And these are used for anything from building facades to floors of airplanes. Elevator cabs are all made out of them. Bus floors, train components, anywhere where you need a stiff, lightweight panel. Our take on it, or improvement to it, is typically how these are put together is they're glued together. The problem with gluing all this together is that they don't have a very good fire rating. You may recall the catastrophic fire in London 5 years ago or thereabouts, where these panels were used on the exterior of a building. And what happened was the extreme heat of the fire, the base of the building, caused these panels to delaminate. And once they delaminated, the core of the material acted as a combination of the core and the glue acted as an accelerant as opposed to a retardant, and flames shot all the way up the outside of the building. So what that's caused is a change in building codes in Europe and coming to America as well, not allowing those types of panels. So what we're doing is we're putting aluminum foam in between these panels instead of honeycomb or plastic foams. And the reason for that is twofold. One is that you can weld it all together or braze it, so it's effectively one piece of metal. And secondly, you get a much stiffer panel because our material is structural to start out with, as opposed to just a separator of these panels. So you get a very strong, stiff panel with the best fire rating. So that's the premise of what we're doing over there. We'll start with Alusion, some of the highlights. As I said earlier, it's principally used for facade applications. We've been operating probably for the last 8 or 9 years in building up Alusion. We've done it on a very low budget, and we're kind of proud of the fact that we were able to build a global brand on such a sort of low cost budget to build up the business. But having done that, we've got several marquee installations around the world. Some of them you probably have seen, like the 9/11 Museum in New York. We clad the foundations of the Twin Towers. The Prada Museum in Milan is almost entirely clad inside and outside with our material. It's an outstanding museum that I'd recommend anybody in Milan to go see. We just did a Google campus in California. We're about to start Google's new headquarters in New York. We've done countless condos, commercial buildings from Amsterdam to New York to Tbilisi, Georgia. We just did a project this year. We do lots of stuff in China, Lithuania. Like, we were probably the smallest and most international company in Canada. The only place where we don't have substantial installations are Canada, with the exception of the Vancouver Convention Center, where the feature wall uses our material. So what we're doing with that is we raised a capital in April of 2021, and that gave us the ability to now resource Alusion properly. So we have boots on the ground in Europe to help our agents in Europe and give them, proper support collaterals, marketing budget, that sort of thing. We hired a senior business development person for the US to further develop our agent and distributor network in the US. And we have a much bigger digital marketing budget, which is how this is sold these days. Print advertising like Architectural Digest is rarely used anymore. So we are expecting a record year out of Alusion based on our pipeline and our order book. And Alusion is a great product for us because it has very high margins, partly because you can't substitute our material. It's a very unique material, and that allows us to maintain great margins. So we continue to resource that business and expect that to grow substantially over the next years now that we've resourced that properly. And as I said, we're coming into a record year this year with Alusion.
Michael, when you're selling that, are you selling it essentially to the architect who's designing it, and they say, hey, we want it to look like this and to have that, and we want an aluminum foam there, and you're the only aluminum foam, so they kind of have to use yours? Or is it at the engineering company level, or how do you, or is it to the end client themselves? You say, hey, you should put this facade on your building because it looks really cool.
Typically, the process is you have to engage the architect or designer first. They come up with a concept for a new museum, building, condo, commercial building, what have you. And once the architect has decided that that's the look they're going for, then they have to convince the owner that it works for the owner and that the pricing is right, and then it works from there. So the lead times for larger projects can be a couple of years. So that gives us it's both good news, bad news. It gives us visibility into what our order book is going to be far into the future, but it's a relatively long lead time. the engineers only get involved from the perspective that the material is very light. So it does have other attributes other than the cool factor or the aesthetic factor of the facade. So if you can imagine, if you're typically hanging, say, precast concrete panels as a facade or marble or granite, they weigh 100 times more than what aluminum foam weighs. So the system that holds or carries the panels, suspends the panels from the side of the building, is much less robust than what you need for typical materials. So it does have benefits along that line as well, but it's mostly the cool factor and the very contemporary look that you can bring to a building using our material. So moving on to smart metal, as I said, I'll leave automotive to the end, but in military, we've been in military for a considerable amount of time. We were approached by the US Army back in, I believe it was 2007, 2008 timeframe. And they were interested in just the attributes that I talked about, the blast wave mitigation. So we got into it based on threats to the Humvee for the US military. And this is going back some time when they first invaded Iraq and Afghanistan, the US Army, that is. And they were finding that the majority of their casualties were coming from the Humvee fleet. So they commissioned us together with AM General, and who builds the Humvee, and Plasan, who is probably still the foremost blast mitigation experts in the world out of Israel. They put us together to design a kit that went underneath the Humvee to protect against IEDs. So we spent a lot of money, got certified with the military with our material, finalized the kit with this triumvirate. And unfortunately, in 2012, when we were ready to go, and this was a very large contract for us, it's about $350 million contract in foam alone. Obama, who was in charge at the time, announced that they were pulling out of Afghanistan and Iraq. And as a consequence, they weren't going to retrofit the Humvee fleet. They were going to wait for a next generation vehicle. So that sort of got us into the military business. We have a number of things that we're working on currently. We've been working with an Asian military vehicle manufacturer for many, many years, and we're finally at the stage where it's fully designed, and the first military customer has done the testing for it, and we are expecting POs for the beginnings of serial production orders for that particular vehicle. And that it will likely start slowly. We announced that some time ago, or not some time ago, but 6 months ago. It'll ramp up slowly with the military itself, that country's military. But the opportunity for us is about $50 million globally, because it's a vehicle that's used by virtually every major military in the world. And we expect that to ramp up over the next couple years, and then, be a substantial contributor to our sales and bottom line going forward.
The original contract that died with Obama, that was a retrofit kit where they retrofit the existing Humvees. Is that right?
That's right.
And this current contract with the Asian military, is that for new builds, or both new builds and retrofits, or how are they applying the technology?
It's retrofit. So
Okay.
there are a lot of vehicles, derivatives of the base vehicle around the world. And it's a retrofit kit, basically, that fits underneath the underbelly of the vehicle.
All right. So
a very similar concept.
But that could be that's a global market. It's one military is sort of starting to adopt it, and if others see the use and value, that could grow from there.
Yeah. So over the past number of years, we've been operating on a shoestring budget. So we had to pick our spots carefully, and this vehicle was very similar to the Humvee. So our learnings from the Humvee were easily translatable to this particular vehicle. What we're seeing right now with the war in Ukraine is a couple of things. Military budgets globally, particularly in Europe, but I'd say globally, are being upped. I think people's concepts of warfare prior to this war were very different than now that this war has started, and it's very much a traditional warfare where troops are being carried in tanks or troop carriers. It's not asymmetric warfare that we were seeing in places like Afghanistan and that sort of thing. So people are revisiting their vehicle fleets, and I think we're going to have a very significant opportunity to do what we originally did for the Humvee, or were to do for the Humvee, and we're about to do for this Asian military vehicle. The other thing that we've been working on for a couple of years is this is with a partner in the States, developing multi-threat panels. So where the military is going with this concept is they want to be able to go out into the field and put protective walls or sort of huts around sensitive equipment, barracks, army barracks, mess halls, everything like that. And they want it to be sort of Lego-like, so that they just construct these quickly on the field. And they have to be able to protect against virtually every threat, whether it's electromagnetic pulses, thermal, acoustic, it's got to be lightweight, blast energy, shrapnel, everything. So this is sort of a multi-layered panel that the company we've been working with has just very recently got certified. And we believe it's, collectively with them, believe it's a very large opportunity. And we're expecting that to start ramping up this year. As I said, they're certified, and they ultimately would like to see us build a plant in the US, which is what the US military always wants. I don't think we're there yet in terms of how it's ramping up, but the volumes we're anticipating out of that business are substantial. So military, the other thing we've done is we've put a senior business development resource onto military, something we've never had. And we've also brought design capability into military. One other thing we're working on is, this is with the assistance of ADI, which is a lobbying consulting firm that we've engaged out of Washington, is that the military is moving towards revamping all of their supply vehicles. They currently have somewhere around 30 vehicles that provide supplies to the troops, munitions, all that sort of thing. They want to reduce that to 3, and they've gone to outside of the military to more traditional Class 8 truck manufacturers like Volvo, International Harvester, people like that, and they want them to come up with the concepts for 3 basic platforms. We are working with virtually all of them to get several components onto these trucks, not just underbelly protection, but lightweighting, crash, everything. So that's a longer term initiative, but we believe that we'll be successful in getting onto this new fleet. And in the kind of mid to long term, I think that'll be a very nice business for us. So moving on to nuclear, we are seeing increased activity in nuclear, and I believe, again, it's based on the war in Ukraine. Because of the energy crisis, I think countries like Germany are re-looking at nuclear power in the short term, so mothball generators, that sort of thing. Most of our business comes out of France, of course, which is the most prolific of nuclear users in the world. But we are seeing quoting activity further afoot from France. We do have a distributor, Nuvia, out of France, who is a very significant nuclear contractor there. They white label our product. And as I said, we're seeing better quoting activity. And we think this year we're going to get some decent orders out of the nuclear business.
And on the nuclear, is it all on that elevator crash mitigation system, or is there any other sort of radioactive elements or other sort of catastrophe prevention uses?
I think there are lots of opportunities in nuclear. We had to pick our spots in the early days as to where we wanted to get certified and that sort of thing. So right now we're focusing on that, but as the business grows, I think there's opportunities to expand uses around nuclear. Our material fits very well with a lot of the dangers that they face. So before I get to automotive, I'll talk about our joint venture in Spain. As I said, a plant has already been built there. We were about to engage in final commercial trials before COVID started. COVID sort of disrupted everything for us because our partner had to shut down, and Spain is still sort of in difficult economic situation. So they are right now sort of working on their base business. The other thing that has slowed us down is that the final brazing trials, the at-scale brazing trials that we were conducting on our own in Hungary, where our chief technology officer resides, we weren't able to get access to proper sized equipment to do full-size trials. So what we're doing now is we've worked extensively with Rio Tinto, who is our specialized aluminum supplier, in a couple of fronts. They've helped us develop a new alloyed foam specifically for this application. So a higher melting point foam with different attributes that our partner was looking for. Now they're also helping us with getting access to appropriate equipment to do full-size trials for brazing. They, of course, have an interest in helping us because they supply our material and they see a massive market for these panels. Just to give you some context, the global market for panels, these aluminum sandwich panels, is somewhere between $3 and $5 billion. So our partner sells about $500 million worth of these panels a year, and their expectation is to ultimately convert all of their production to these types of panels. So we see this as a very substantial line of business, and are continuing to put significant effort into it. It's great to have somebody like Rio Tinto helping us out, paying for this stuff, and sort of validation that there's a massive market for this as well. So having said that, Rio Tinto and NRC are doing the work currently. Problem with NRC, of course, is they're quasi-academic, so it's very difficult to put an accurate timeline on when their work will be done. But I'm hoping in the next couple of months that we'll be through the trials. Then we'll be able to send samples over to Spain. And we think that by the end of the year, we should be through commercial trials in Spain, and then start our commercial launch early in the new year. It's been a long time coming. We've had setbacks, of course, because of COVID and a couple of things, but we're confident that the technology works. We've invested a lot of time and effort into it, and we believe it's worthwhile because of the size of the market and sort of the compelling reasons to introduce this into the market.
What exactly, when you say brazing, what exactly does that mean?
Just basically welding.
Okay.
You're welding aluminum foam to the skins on the top and bottom. Sounds simple, but if you can imagine that aluminum foam is mostly air, trying to just weld that little skin that we have and the points at which the cells come together to the skin is a very complex thing without the whole thing collapsing. So it's we're most of the way there. We figured out how to do it and the equipment that's needed, but it's a tricky thing to do. But once we've got it under our belt, as I said, I think it's going to be very worthwhile.
And so you have the foam core, and then you braze or weld the two just thin sheets of aluminum onto either side, so you can't see the foamy stuff.
Yeah, the foam is just a substrate, or the meat in the sandwich. And generally, its only purpose is, if you think of an I-beam in construction, you have sort of two beams like this, and then a beam that runs vertically. And the purpose for the vertical beam is just to create separation between the two horizontal beams. And they're really what take all of the load. And the further you can spread the distance between the top flange or the top piece and the bottom piece, the stronger that particular beam is. And it's the same thing, same principle that's applied to sandwich panels. If you can make them, the more you separate them and the thicker the skins are, the stiffer the panels are. That, of course, isn't always the objective. They're looking for stiff but lightweight panels. So you can engineer them any way you want, but that's the principle.
It's been several years since you announced that the Spanish joint venture. And are you building the factory, or and I'm sorry, the name of your partner is just slipping my mind. Are they kind of licensing it from you, and then it's sort of a profit share on the licensing, or are you having to actually cut checks to help build out the facility?
Well, it's a 50-50 joint venture. And the business model is that we have a plant over there that creates the raw product. Then that raw product is sold to one customer, which is Alucoil, and they would finish it to whatever spec their end customer has. And the reason we like the model is that we don't have the risk of building up distribution or anything like that. They already have distribution around the world for their product, and we have one customer. And there's going to be minimums that they have to take from the plant and that sort of thing. And they're also our partner. The way we're starting it is that the plant that's there doesn't have a foaming front end yet. We wanted to sort of perfect the brazing first. So once that's perfected, we'll start shipping sheets of aluminum foam to Spain initially. And then
from your Canadian factory.
Yeah, from our Toronto factory.
Yeah.
Or Mississauga-based factory. And then once they are comfortable with the process, we'll add a foaming front end to the plant. So, we're responsible for that. They're responsible for the other aspect of it. So we haven't had to invest a lot of money into that venture, aside from all the development work that we've done so far. But we will need to invest in a foaming front end, if all goes well, probably within 12 months. Spain.
All right.
Again, before I get to automotive, I'll talk a bit about our facilities. We have a plant in Mississauga that was starting to get long in the tooth. It's about a 20-year-old plant, so the equipment is mostly 20 years old. When we raised the money about a year and a half ago, we allocated about $2 million to upgrade the plant for a couple reasons, primarily to increase capacity. So we're now at a point where we can get about $75 million of capacity output out of that. We also are looking at automation and efficiency and whatnot to take costs out of the process, and also to prepare us for serial production for both military and automotive. So ISO programs and that sort of thing, quality systems that automotive expects. So that is well underway. It should be finished in the next, I'd say, 3 to 6 months, just in time for when we expect a ramp up to start in military and hopefully automotive. So very happy about that. And then moving on to automotive. So we've done a couple of things. We were very substantially into automotive in the early days of Cymat. That's the early 2000s. And I would say that we had a development program with virtually every OEM in Europe in the early days, from Mercedes to Porsche, BMW, Audi, Fiat, Opel, Volkswagen, virtually everybody. And the premise was that that was just the beginning of lightweighting, and European OEMs particularly were at the forefront of lightweighting their chassis and components in their cars. The problem was that we weren't ready for automotive. We couldn't produce the product as consistently and regularly and at a cost structure that was appealing to automotive. So we were forced to withdraw from automotive and essentially go back to the drawing board, understand the science better, and be able to produce a more consistent product, regulate the density and cell structure better, and what have you. So that's all behind us. We haven't really dabbled in that world since I guess 2000, 2006, 2007, when with Valeo, together with Valeo and George Fisher out of Switzerland, we had a component that was ready to go, a crash box for their front end module. That was Valeo's front end module out of France. And then the financial collapse came and that was derailed. So we decided at that point to essentially pull out of automotive because we didn't have the resources to continue. What drew us back into automotive was really the electric vehicle revolution. So I'll give you some data points. Electric vehicles, the battery for, say, a mid-size SUV, the cells alone can weigh up to 2,000 pounds. To protect that battery, the only way it's done today, and nobody's really figured out how to optimize that, is you put a steel box around it, reinforced steel box. And that weighs anywhere from 300 to 400 pounds. So total of the battery and its enclosure is about, call it 2,400 pounds. So if you were to guess what your small SUV or sedan in the driveway weighs, I think you might be surprised that it weighs the same as what the battery in an electric vehicle weighs. So these vehicles are tanks because of the battery. And there's nothing they can do about the cells until solid state technology is introduced, and that's years and years away. So really, the only thing that they can do on the electric vehicle side is work on the enclosure and figure out how to take weight out of the enclosure. The other thing that has changed in the automotive world is once you take that big engine block out of the front of the vehicle, the dynamics of crash change dramatically. The engine block actually plays a huge role in front end crash, together with the bumper and the rails and what have you. You take that mass away, and you have to figure out how to take those forces much differently. So they've had to rethink sort of the front rails and bumper systems and what have you. So that plays perfectly into our material, both those things. The other thing we've done is that we sort of figured out that it's not terribly effective to just go to the car makers or the parts industry people and say, we have a very effective material that you'd like, and expect them to do the design for you. So we've taken a more component-centric approach, and we started that by engaging with Tesseract out of Arkansas. They're an engineering design house that specializes in crash mitigation, particularly in aluminum components, and particularly using our material inside aluminum components to optimize crash. So in fact, we invested in them last year, and I sit on the board so as to make sure that our interests are aligned. But that partnership has been particularly effective for us, because now we can approach OEMs and tier ones with a component solution. So we have, as I said earlier, honed in on the electric vehicle space. And initially, what we decided the most effective area to work at was the battery enclosure. So that brings us to the announcement that we made a couple of days ago, or I guess a week ago or so. We've been working with this global car company for almost a year. They initially engaged us to develop an all aluminum battery enclosure for a light truck that was years away from being launched. And they liked the design that we came up with together with Tesseract. And then they pivoted on us and said, well, actually, what we'd like you to concentrate on first now is an existing vehicle that's in the market. And we want you to optimize a certain part within that vehicle or the enclosure. So what the part is it's a series of beams that reinforce the steel box. So if you can imagine, a typical floor in your house is you have plywood on top and beams running every, say, 16 inches. Well, they reinforce this box the same way. So there's 7 beams running across the bottom, 7 beams across the top. These are currently made out of high strength steel. They're very complex members, and they were designed mostly to just create the rigidity and strength to hold that 2,000-pound mass. So you can imagine that 2,000 pounds going over a pothole, the dynamic loading effects of that are very substantial. So, you know, it was optimized really for strength. So they came to us and said, what we'd like you to do is come up with an aluminum alternative to that. So we did, and we designed it and it did some simulations for them. And they were looking particularly for weight reduction, taking complexity out of the part. And of course, everything in automotive is about cost. So they're looking to take costs out of the part as well. So we were able to satisfy them with that, and then entered into the contract to fully optimize that part. The other interesting thing is that they're paying us for this, which is very rare in the automotive industry. We've certainly in our history never been paid for any development work that we did for the car companies. So it's unusual that they're paying us for this. So the way it works is that we optimize the design, do simulation, FEA analysis, which is computer simulation. And then if that's acceptable to them, then we move to physical prototyping, which should be in the fall. And that's to correlate performance of actually testing these members out and correlating them to simulation results. And then finally, the negotiations for serial production. So a couple of takeaways from it, which we find particularly appealing, is that it happens that this particular battery box design is common to about 2/3 of this vehicle manufacturer's electric fleet. And so that makes the volumes very substantial, upwards of 1 million units per year. Sorry about that.
All right.
And secondly, it's termed a running change, which means that they're not waiting for an overall platform change to make the switch in this particular component. So because they're not changing any of the architecture of the battery itself or of the enclosure, we're just substituting part for part. It means that it's a very compressed timeline for us to get into that vehicle. So I would say that best case would be 12 months we're into production for this particular vehicle. More likely case would be probably 12 to 18 months. But all the sort of signals they're giving us and the timelines they've placed on us suggest that they would like to replace this part very quickly. So give you some metrics, it's hundreds of dollars per vehicle of foam alone. The component is ours. So the component itself would probably be twice the value of that, if not 3 times the value of that. As I said, we were asked to quote for up to 1 million vehicles. So it's very substantial for us. What we likely will do is we'll partner with a major tier 1 to be the integrator. In other words, we would sell them the foam that goes into the piece, and they would actually assemble the piece and be the direct contact with the OEM. And that's just to sort of allay any fears that they may have of dealing with a small company like us on such a large contract. So we want to tick as many boxes as we can to give them comfort that we're not going to, create disruption on the assembly line or anything like that. So we are very excited about it. They've also asked us to, after this design phase is over, to look at other aspects of that battery box design, particularly side impact. That's some of the work we did for them earlier on an earlier version of a whole new aluminum box. So they are, we believe, committed to moving to lighter weight materials on the box, aluminum particularly, and our designs and technology. So we hope to have a long and fruitful relationship with this particular car company. The other thing is that we're not exclusive on this particular design. And as I said earlier, most of the boxes that are used in electric vehicles use a very similar design. So it's very easy for us to take that particular application and go knock on other doors and offer up that design. And it becomes easier for sure once you're in the market with it and you have the credibility of already having that part in the market. So as I said earlier, we're very excited about our prospects for automotive, particularly, and the numbers sort of dwarf anything else we do, and makes for a very exciting time at Cymat right now.
With the structure of the auto parts deal, at least initially, is you would manufacture the foam in a certain shape or whatever, and density, and obviously whatever specifics on it. You would send it to the auto part group, and then they would do a little more value add, and then they would then ship it to the client, the end user.
Yeah, and obviously because this particular car manufacturer is our customer, they're not forcing us to partner with an auto parts company. You know, we'd get some sort of royalty or piece of the revenue for the component as well. So not just the sales of aluminum foam, but something on the piece as well.
All right, you've talked. You're upgrading your manufacturing facility to be worth around $75 million worth of potential revenue. How is I'm guessing that in terms of actual quantity of product, is it sort of the rate limiting aspect, sort of the volume that you can do, or the tonnage of aluminum, or kind of a combination of sort of size of how many sheets or panels or can you, and I guess, can you talk about your manufacturing facility a little bit more on like how you kind of quantify the output and how that works?
Sure. Like, capacity is very much SKU dependent.
Yeah.
And right now, you know, Alusion has, I don't know, probably 10 SKUs. And so if you're to load the plant with Alusion alone, which is principally what we've been doing, there's a lot of post-processing associated with Alusion, and you're running different densities every day, and you know, they're custom order products to a large extent. So that limits the capacity. So I would say that you know, the 75 million is based on an estimate of how much Alusion we would run through the plant, how much military, and how much automotive. If we were to just dedicate that plant either a military SKU or one automotive SKU, we can get substantially more production out of the plant, because we're not doing that much post-processing. In fact, we're doing very little post-processing then in the plant, and we're shipping slabs of aluminum basically to the part manufacturer, and they'll cut it and insert it into the part and that sort of thing.
And you're not, obviously, whenever you do a changeover, that there's new setup time or whatever, so you just lose efficiencies if you're having to switch SKUs.
Yeah, I mean, the process is flexible enough that we can change densities on the fly. The limiting factor tends to be the post-processing.
Okay.
And Alusion takes a lot of post-processing before it gets shipped out as a finished cladding product or whatever. Military has next to nothing, you know, unless it's these kits, and the kits are a little more complicated because we're having to cut the parts to fit the kits. But we can always do that outside of our existing plant and dedicate the plant just to aluminum foam casting. And that way you'd get the most efficient use of that plant. And I would guess we could probably push that to about $100 million worth of output if you were running just one or two SKUs around the clock with our equipment.
On the military side, do you have a manufacturing partner where they could maybe do some of the cutting or post processing, or that's on your shoulders, and then the client puts the kits together with the other components? Is that how it works?
Well, this the military vehicle contract we're expecting to get our first POs for shortly. We cut aluminum components or aluminum foam components for the vehicle manufacturer, who then puts them into the kit. So we design the kit together with them. With respect to the threat panels, which we think is going to be a bigger business actually, we just ship 4x8 panels basically to our US partner, and they integrate all the other layers of this particular panel together. They have some very substantial companies in the consortium that they're working with that provide other aspects of the material. So again, we're just a component supplier or an element of that panel supplier, which is very simple for us, which is
All right.
cast the panels, ship them off.
You're sort of elephant hunting here. There's some really big elephants in your scope. It sounds like, is there a risk that you're going to run out of capacity soon? You're going to have to build a new facility, and well, hopefully that'll be sooner than later. And what does it take to build out a new facility? Would you add on to your existing one? You talked about opening a facility for the military in the US because that's how they like it. And what would the CapEx on a new facility kind of in the order of magnitude look like?
Well, that's a lot of questions. I'll start with the first one.
I just throwing a whole mess of stuff at you. Sorry.
So your first question was our existing facility and when do we run out of capacity? Well, it very much depends on the mix and how quickly military and automotive ramp up. So realistically, I think certainly for the next 12 months, we're going to be okay in that facility. With respect to expansion, we would likely put our first plants in the US simply because, you know, the automakers and military, you know, want you to have a US presence. So in terms of CapEx, it depends on the volume that you're looking for. Probably to replicate what we have in Mississauga, Ontario, it would be somewhere between $5 and $8 million to replicate what we have. So it's not substantial CapEx. A lot of the components are off the shelf, like the induction furnaces or standard casting furnaces in the aluminum industry or metals industry. It's really only the black box that foams that is proprietary, and we've built enough of those over the years, fabricated them, that we brought the cost down substantially. So it's not a lot of money to set up a new plant, which is unusual in the business that we're in, which is kind of heavy industry.
Yeah. And what is your IP? Are you patent protected? Is it just trade secrets because you've been doing this for so long and you know which ceramics to mix in? And can you just talk a little bit about the moats around your business that you have?
So our strategy is a combination of patents and know-how. And so a little bit about the history of aluminum foam or stabilized aluminum foam, which is our particular aluminum foam. The base patents that Alcan, the inventor, and Norsk Hydro out of Norway, that they filed expired a number of years ago. So what we've done to sort of protect ourselves is we have equipment and process patents around the base concept patents that we think provide a significant amount of protection for us. There's a lot of know-how in this because there's as much art as there is science in foaming, particularly the way we foam. But having said that, we are engaging in sort of a new IP initiative, particularly around brazing and, you know, the new alloys that we've created, foam alloys and new equipment, efficiency equipment and that sort of thing. So we've got a big push on and expect to be filing a substantial amount of patents in the near future. Patents are expensive as well to, you know, file and maintain globally and that sort of thing. And we just didn't have the budgets over the last number of years to do that. But now that, you know, we have a healthy treasury and, you know, Alusion is essentially paying all our bills and generating free cash flow for us, certainly this year. You know, we can engage in those sorts of things and are engaging.
All right. Okay. And all right. Some questions from the audience here. What is happening with the other Tesseract projects previously announced? Because you've been working with them for a little while and you've announced some other projects.
Yeah. So we have relationships with, a number of other car companies and parts manufacturers, and Tesseract has projects themselves as well that they're working with car companies with their UDO device and that sort of thing. They are ongoing for sure. The issue right now is that this particular automotive application that we're working on, I won't say it's all consuming, but it's mostly consuming for us. And until the prototypes are built and shipped to the car company, I would say that's taking up 75–80% of our engineers' time and Tesseract's design team's time. So yeah, you have to prioritize. We're both small companies with limited resources to a certain extent. Tesseract more so than us. So you have to pick your spots, and this is the spot that we've picked for the foreseeable future. And as time permits, and they can also bring in more resources, design resources, we'll be able to put more effort on the components that we've been working on at our various stages of development, with other automotive parts or automotive car manufacturers and parts suppliers.
Well, and I think with the long design cycles within the automotive industry, if there's a fast track project that could be generating revenues and so forth in the next 12 months or so, yeah, that's seems like a very clear way to focus on that and get that going and prove that out in the automotive industry.
Yeah, and quite frankly, the other projects, a lot of them, they're expecting us to do the development work for them. This is such a unique situation with this car company where they're paying the entire freight for the development work and our overheads and what have you. So,
yeah,
that's where the priority goes, and that also means that they are, much more. There's a sense of urgency, I guess, to the part as well. So, again, we haven't by any stretch abandoned the other things that we're working on, but this is just so high priority for us right now that it is mostly consuming for us.
Well, and it demonstrates a level of seriousness about this product if they're footing the bill for the development to fast track it. So that's great. All right. As well, you have a partnership. You're within, I believe is it the Aero project, the Canadian car project, the concept vehicle out of Canada for an sort of Canadian EV. What's going on with that?
Yeah, so we have a couple of components in that particular initiative. That is one of the other active sort of initiatives that we have because we're committed to that. Not quite sure what the ultimate timeline will be, but we have to have our components ready, I believe, within 12 months for that particular initiative. You can learn more about the initiative on the APMA website. It's the Project Aero, and what it is it's sort of highlighting Canadian automotive technology. It's not just Canadian companies, but it's automotive companies, global parts suppliers that have a footprint in Canada are participating as well. And it's sort of best of breed of technologies for electric vehicles. So we were quite honored to be asked to come on to that vehicle with some of our componentry. And it gels very nicely with some of the work we're doing with this car company and some of the other car companies, particularly around the battery box and front end crash mitigation, which I talked about earlier, which is critical in electric vehicles.
All right. Okay. We were an hour into this, so I really appreciate you taking the time to talk with us, Michael. What sort of news flow should we be expecting out of the next months here, or let's say through the end of the year? What kind of news do you hope to release at that point?
Well, I mean, this component we're working on for the car company, it's going to have various, gating stages. So, as we get through optimization of the design, we will put, a press release out. And then as we get through physical prototyping in their ship, we'll put a press release out. And then, so we will be able to sort of provide a guiding path to, when we expect to be into production on that initiative. As I said, the multi-threat panels in military, we are expecting that to ramp up this year. So as we start to get our first orders, we'll provide some news around that. And also, as I said earlier, this long-term military vehicle contract, or a vehicle that we've been working on for many, many years, we are expecting that to go into serial production imminently. So, as we start getting our first POs, we'll be announcing that. And, we always have marquee projects that come up in architecture. We'll be announcing those. So I think we're going to see a reasonably steady flow of news going forward. It's, everything seems to have come together for us all at once here. That's both, it's wonderful for the company, but it's also daunting. So we are juggling a lot of things. We brought in a lot of senior resources to help out, something we haven't had for many years, and that's helping for sure. And new engineering resources and the plant and what have you. So that's helping, but still, we have a lot of pokers in the fire right now, and managing them all is a challenge for us. But we're enjoying it because we haven't had this kind of activity for a long time at Cymat.
Good to be busy. I agree. All right, Michael, thanks a lot for taking the time to talk with us today. That was very interesting, and you got a lot going on. Thanks a lot. Have a great summer, and hopefully we'll get you back here in a while, and we can discuss how things are rolling out.
Great. Thank you for having me, Martin, and for everybody who was listening in. Have a wonderful day. Thank you.
Cheers.